Vector summation integral calculus. We are proceeding non-ending vector summation and integral calculus. I believe that now everyone should agree on this, that dividing problem into n different parts, it make more sense than anyone would expect. Dividing problem into n different parts and solve part by part and then sum it. Okay, how I can divide problem into n different parts, provided all different parts must be non-overlap, must be unrelated to each other. Okay, if I am dividing, consider there are kind of cars, car. There are car, and I'm doing some operation, doing some mathematical computation on car. I can divide some car which has green in color, some car which has red in color. Okay, but if car are painted in red and green together, then I cannot divide it because there is overlapping out there. If I am dividing my problem into n different parts, like I'm dividing all the car, I'm doing some computation over the car, and then I'm dividing all the car in a manner that is called color of the car. And then I say I have n color of car, let's divide color by color. But what about few cars have multiple color? Then you cannot divide. Concept is dividing problem into n different parts only when all parts are all parts are non-overlapping to each other. They are unrelated. If they are unrelated, then only we can divide problem into n different parts. Anyway, now we are in a phase of calculating the if there are three things that we have seen as far as bank related problems are concerned. As far as bank related problems are concerned, there are three things that we have seen. What are the three things? One thing is that there is a fixed deposit account in bank. Someone is opening a fixed deposit account and then he is depositing a money in a bank, considering that after t is small, after t years, the amount that he is seeing, what he has deposited, after t-year amount will be more. Bank is saying that we are doing compounding every year. Compounding means principal amount would become principal amount would change after 1 year. Principal plus interest after 1 year, that will become new principal. It is as good as someone receives interest. Consider that bank is giving C% of interest. C, bank is giving C% of interest, yearly interest. Bank person has deposited amount Y0 amount. Y is the amount of the fixed deposit at any time. Y. What is the amount that is in fixed deposit? Y. Okay. If person has deposited beginning money, initial money in the fixed deposit, that is called Y0. Y bottom right as a subscript Y0. Y0 money he has deposited in the account at the beginning only. And C is the interest that bank is giving per year. After 1 year, he is seeing that amount is Y0 plus Y0 into C. Y0 plus Y0 into C. Okay. If bank is saying that we are giving C percentage of interest rate every year depending upon how much you have to pay, there is no compounding is concerned. There is no compounding is concerned. Means 5%, if bank is saying 5% every year you will get. It is something like if someone has deposited $100 into the bank or 100 rupees into bank, after 1 year, the money will become 105 rupees. After 2 year, money will become 110 rupees. After 3 year, money will become 115 rupees. Because 5% it is giving yearly basis. A person is very smart. After 1 year, he is going to the bank and he is seeing in his account it is 105 rupees, $105, because he has deposited 5% interest he has received. Okay, he is withdrawing the money and then depositing again. knowing that now interest will come on top of 105 rupees, not on the top of earlier 100 rupees. Okay, at the end of 2 years, he is withdrawing money again, and that will be more than 111, 112 or something like that. And he is depositing again, saying he will get 5%. Okay, rather than person doing this, bank is doing this. That is called compound interest. Every 1 year, principal amount and interest amount together, they would become principal amount. This is called compounding every year. So we have seen it. Okay, if compounding every year happens, then at the end of t year, y would become y0 into in bracket 1 plus c to the power t. People know this is compound interest. Y equal to y0 in bracket 1 plus c to the power t. After t years, that will be the amount after compounding. Now there is another bank. They are saying that we are compounding. We are compounding we are giving C%. That is true. But we are compounding every month. Every month. Then every month how much interest you are giving? C by 12. Every month you get C by 12 interest, and at the end of month principal amount and interest amount, they will come together. Then next month at the end of 1 year you will get more than C. Okay, in that fashion, person is depositing amount there. Okay, in that way, the calculation will be y0 in bracket 1 plus c by n. N is how many division you are making in 1 year. Here it is 12 division. C by 12, c by n to the power n. This is for 1 year. N into t for t years. This is new calculation y0 in bracket 1 plus c by n to the power n into t. If n is more than 12, consider one bank is there. Bank is saying, we are doing compounding every day. What interest you are giving? Then it is c by 365. Everyday compounding. Then n is growing. Number of division we are making in 1 year is growing. If n tends to infinity, then 1 plus c by n to the power n will become e to the power c. We have proved many times. Please watch our previous video. 1 plus c by n and bracket close to the power n, where n tends to infinity, it will become e to the power c. So net, this is also called it is also called continuous compounding. Every day, if someone is compounding, it will come under continuous compounding. Someone would say, whatever, every second. Yeah, yeah, it is more towards continuous compounding. It will become y equal to y0 into e to the power ct. Y equal to y0 into e to the power ct. Earlier it was 1 plus c by n bracket close nt. 1 plus c by n to the power n become e to the power c, e to the power ct. Okay, now next question is arising. Consider that in the fixed deposit account there is some external person and he is depositing S amount every year. He came to know about my fixed deposit account number and he is a well wisher, and he is depositing S amount every year. If at the end of 1 year, how much money I have in my account? Y0 into e to the power ct, where t is 1, e to the power c, plus S amount someone has deposited. At the end of 2 years, at the end of 2 years, how much money I have in my account? Y0 e to the power ct plus S. This is the principal amount at the end of 1 year, into e to the power ct, because 1 year you will get again e to the power ct, where t is 1, e to the power c plus s, because s amount someone has deposited. So at the end of 2 years, someone will have y0 e to the power c into 1 e to the power c plus s and a whole bracket close e to the power c. It will become y0 e to the power 2c plus s e to the power c plus s, because at the end of 2 years, person is depositing S amount in the account. So at the end of T year, the net money will be Y0 e to the power Ct plus S e to the power C T minus 1 plus e to the power C T minus 2 plus e to the power C T minus 3 plus e to the power C T minus T e to the power 0. That will be the money in the account after T years. The question is arising, what are the two? There are two terms here. One is y0 e to the power ct, understandable. Another is s, and in bracket e to the power ct minus 1 plus e to the power ct minus 2 plus e to the power ct minus 3 plus e to the power ct minus t e to the power 0, that is 1. If this is the net summation, now net summation is e to the power c t minus 1 plus e to the power c t minus 2 plus e to the power 0. What is this? Let's divide it into t parts. If it there are t terms, one term is e to the power c t minus 1, second is e to the power c in bracket t minus 2. There are t terms, that th term, the last term is e to the power c t minus t. It starts with minus 1 and goes till minus t. There are t terms. Let's divide. What is the addition of this? Okay, addition of this. Rather than computing everything, let's divide it into n different parts. N different part means first is e to the power c t minus 1. That will be e to the power c t minus x. Next is e to the power c t minus x. Last is also e to the power c t minus x, where x is variable. But all are same. I can say I have a function. What is the function? Function is e to the power c t minus x. Okay, what I'm trying to show is that person who is trying to solve s, and in bracket e to the power c in bracket t minus 1 plus e to the power c in bracket t minus 2 plus e to the power c t minus t. Now he is thinking that this can fall in one variable function, where variable is x axis, and function is like this, where x is 1, then it is e to the power ct minus 1. When x is 2, then e to the power ct minus 2. Means, what is e to the power ct minus 1 is the vertical at x equal to 1. X equal to 2, another is vertical. X equal to 3, another is vertical. When x equal to t, the vertical is x e to the power ct minus t. Means he is saying there is a function called e to the power ct minus x, where function is sampled discrete manner. Function is sampled at x equal to 1, 2, 3, 4, 5, 6, 7, 8 up to t. Now someone has to calculate all the verticals. Can I add all these verticals? Then we took one example. Example is, consider consider there is a function called x. This is x-axis, and there is a line called x. X is sampled at x equal to 1, 2, 3, 4, 5, 6, 7, 8. I'm sorry. This is x-axis, this is origin, and this is 1. I have sampled, this function name is x, fx equal to x. When this x is x, fx means height. When x is 0, then height is 0. When x is 5, height is 5. When x is 10, then height is 10. Make sense? Okay. Now it is 0 to 10. When x, let's divide 0 to 10 into 10 different parts. Into 10 different parts. If it is in 10 different parts, so let's begin at x equal to 1. Then height is 1. Let's begin at x equal to 1 by 10. I have divided 0 to 1 into 10 different parts. When x equal to 1 by 10, height is 1 by 10. When x equal to 2 by 10, height is 2 by 10. When x equal to 3 by 10, height is 3 by 10. I am adding 10 different height. One is 1 by 10, 2 by 10, 3 by 10, 4 by 10, up to 10 by 10. How much it will be? Someone can compute 1 by 10 plus 2 by 10 plus 3 by 10 plus 4 by 10 plus 5 by 10 up to 10 by 10. How much it will be? Okay. Then we suggested one thing. What is the equation of this? What is equation of this? What is equation of this? Equation of this is called fx, and fx equal to x. So what I'm trying now, summation I equal to 1 to 10 fx, where fx is the height, where it is sampled at I equal to 1, 2, 3, 4. Fx is x, or I can say summation x equal to 1 to 10 x. Okay, I'm sorry, x by 10. X by 10 means 1 by 10 plus 2 by 10, like this up to 10 by 10. But concept is, can I find it through integral calculus? Because after all, who will do the summation? Consider I chop it between 0 to 1 into 100 part. Then 1 by 100 plus 2 by 100 plus 3 by 100. Who will solve it? And this equation is x. What about equation is x square then? Then it will come as 1 by 1, and then I'm chopping it into 10 sections. 1 by 10 whole square plus 2 by 10 whole square plus 3 by 10 whole square, person will die only. So better to come to integral calculus. That is the concept. Can we come up to integral calculus? Okay, if I want to come to integral calculus, then integral calculus always compute the area. If I say this function is fx, that is x, then x dx from x is 0 to 10 will give this area. That I don't want. Why I don't want? Because this area is always constant. If I say fx dx, fx is x, x dx, integration of x is 0 to 1, it will always be constant. This is what the answer is. But what is not constant is, what about if 0 to 1, I chop this into 100 parts, 1000 parts, then 1000 verticals will come into the picture into discrete manner. If that is the case, then 1000, all will have different value. If I add summation x equal to 1 to 100, and then x by 100, summation x equal to 1 to 10 by x by 10, all will have different values, though they go from 0 to 1 only. But fx dx x 0 to 1, it will have one value only. So I cannot go with both are not same. Summation x, summation means sigma sign x equal to 1 to 10 fx, that is x by 10 right now. Summation x equal to 1 to 10 x by 10. It is not same as integration of fx dx x is 0 to 1, because left side is variable. If I chop into 100 times, then it is summation x equal to 1 to 100 x by 100. Okay, 100 times. Someone can see. Consider I chop into two parts only. Two parts. First is 1 by 2. If it is one, this is 1 by 2 and this is 1. So length is 1 by 2 plus 1. How much it will be? 1.5. If I chop in 4 parts, then it is 1 by 4 plus 1 by 2 plus 3 by 4 plus 1. Certainly it will be higher. 1 by 2 plus 1 is 1.5. This is 1 by 4. If I divide into 4 parts, 1 by 4, then 1 by 2. 3 by 4, then 1. Certainly it is higher than that. More we chop, more vertical will get generated. So both are not same. Summation x equal to 1 to n fx is not same as integration 0 to 1 fx dx. But I have to find through integral calculus. Then what I have to do? I have to find out another function called gx. Instead of fx dx, I have to say gx dx, where gx dx integration 0 to x will be exactly same as summation x equal to 1 to n chop I have done fx. Make sense? Okay, now let's proceed. How I can find gx? This is the what we are talking now. Can I find gx, where gx dx integration from 0 to 1 will be exactly same as summation x equal to 1 to n fx? Can I find that? What I am going to talk next is not available in any of this approach itself is not available in any of the book. Anyone can try. What we can do now next what we can do, let's divide into n different parts. Let's divide 0 to 1 into n different parts. Now not takes any point here called x. Then what will be the next point? X plus 1 by n, because 0 to 1 I have divided into n different parts. If this is x, the next chopping will be happen at x plus 1 by n. At x, what is the height? That height is fx. At x, height is fx. That is, I have taken fx and x only. So height is x1. Okay, what is this sub area? First, what is the height here? And then what is this sub area? What do you mean? Fx into 1 by n. 1 by n is the distance here. All the chop has a gap of 1 by n. Okay, this distance is 1 by n. If this is x, then this is x plus 1 by n. 1 by n into fx will give this sub area. If I add all the sub area, If I add all the sub area, it will give the area. Concept is area should be equal to the sum I am making, because the what I want is I want sum of all the vertical, and that sum of all the vertical should be area f gx dx. So this fx, if I see x, then this is fx. Then for integration, I will have another function called gx. That is a different function I am thinking of. Now in gx, if this is x, the next point is x plus 1 by 1, x plus 1 by n. Now if I see, this will go up like a sub area. It will go up like a sub area. This sub area, what is the area what we are seeing? It will be exactly same as what height I am seeing at x equal to fx. If this fx is same as gx, gx into 1 by n at x equal to x, then all the area, all the sub area, if I add dx dx, will be exactly same as f summation of all fx. I believe it is understandable. I have two sides now. One side is addition of vertical, and same thing I'm trying to achieve through calculating the area of any other curve, and from begin to end. Then area of other curve, the other curve will not be same as what we have here. The other curve will be different. So that if I chop other curve into n different parts, then integration means summation of all area. If I say this is gx, this is gx, and this is x-axis, what is gx dx? Gx dx is area underneath it. If this is 1 and this is 0, I can chop it into n different parts. Then it is same as if I take part by part sub area, if I add it, it will become gx dx. Now I have two curves now. One is fx. This is the curve fx for which I want the addition of all the vertical when I have chopped it into n different parts. I have another curve called gx. For fx at x, this is the height. This height should match to the at x what is gx, and then into 1 by n. 1 by n, that this area. If this area and this height are same, then summation of all height will be same as the summation of all the area stripped. Means fx summation x equal to 1 to n will be exactly same as gx dx. So integration 0 to 1. Makes sense? Means gx I chopped into n part, and I took one section at x and x plus 1 by n. That area section, sub area, should be exactly same as what I take fx. At fx, what is the height? If both are same, then I can find gx. Concept is to find gx. Then quickly I can do gx dx, and I can find the area that will be equal to the addition of this. This is the concept, that this is the research based concept that we are pursuing. Now if I divide into 10 different parts, if I have fx equal to x and I chop in 10 different parts, then what is the height when x equal to x? The height is x only. So when fx is x, at x equal to x, fx is x, then what will be gx? X equal to fx equal to gx dx. This is what we are saying. Fx summation of fx at x equal to 1 to n equal to gx dx integration. Or if I take a single value, then fx equal to gx dx. Dx equal to dfx by dx. If fx is x, then it will come to 1. We'll try here. Gx is 1. 1 dx. 1 dx integration from x to x plus 1 by 10, because I have chopped it into 10 different parts. X to x plus 1 by 10. Gx dx should be exactly same as x. One part I am matching it. If it matches, then I can find gx. Now gx dx, 1 dx is x. X is from x to x plus 1 by 10. That will be 1 by 10. Here it is 1 by 10, and here it is x. Okay, means I have to multiply it by 10 into, earlier we had taken 1 and it came as 1 by 10, but expectation is x. It should have been x. Means I have to multiply it by 10 into x. Now let's try again with 10 into x, because this is called successive approximation. Now I have 10 into x. 10 into x dx. That will become 10x squared by 2. Okay, let's take 10 by 2 outside or 10 outside, x squared by 2. X squared will become, now limit is x to x plus 1 by 10. X squared will become x squared plus 1 by 10 whole square plus 2 into 1 by 10 x by 2. Okay, minus x square by 2, or by 2 I can keep down, minus x square. So x square will go away. Now it will remain is 2 by 10 into x plus 1 by 10 whole square by 2. So 2 will go away. It will remain as 1 by 10 into x. Makes sense? 1 by 10 into x plus 1 by plus 1 by 100 into 1 by 2. 10 is outside. If I multiply it 10 with the outside, 10 with the outside, the first term will remain as x only. Second term will become 1 by 20, I think so. Second term will become 1 by 20 or something like that. Okay, 10, hope, something like that. So it will come as x, the way we thinking x, x plus 1 or 10 is out. I'll try again. What we were trying is 10x. First we started with 1 dx. Now it is 10 dx. 10x dx. 10 outside x squared by 2. Or I can keep 10 by 2 outside x square. X to x plus 1 by 10. First will become x plus 1 by 10 whole square minus x square. It will become 2 by 10. 2 by 10x plus 1 by 10 whole square. Okay, outside 10 by 2 is there. Okay, first is 2 by 10 into x. 2 by 10 into x. 10 by 2 is also outside. That will become x only. Into 10 by 2 into 1 by 10 square. It will become 1 by 20. Okay, then we have found the result, but 1 by 20 is different than what we did. Expectation is x, but we got x plus 1 by 20. Okay, now what we have to do? So now we have to minus subtract with 1 by 20 to come to the result. Now we earlier we had 10x. Now it will be 10 and in bracket x minus 1 by 2 make 1, minus 1 by 20. Instead of what is expected x and what we have now x plus 1 by 20. So 1 by 20 I have to subtract what we did earlier. So earlier we had 10 into x. So 10 into in bracket x minus 1 by 20. If I solve it, it will become 10x minus 1 by 2. Let's try with 10x minus 1 by 2. We'll start again. 10x square. This is called successive approximation. 10x square. 10x square by 2 minus 1 by 2x. Makes sense? Now 10 by 2x square. 10 by 2x square will come as x plus 1 by 20. We have seen it. If I put limit x to x plus 1 by 10. So 10 by 2x square will exactly come as x plus 1 by 20. Now settle down. Now let's settle down. Minus 1 by 2x, that has come as integration. Minus 1 by 2 I can keep outside. X will become 1 by 10. X plus 1 by 10 minus x 1 by 10. Minus hope. It will become minus 1 by 2 outside and then inside 1 by 2, minus 1 by 20, and here 1 by 20 gone. Only x is remaining. Amazing, mind blowing. So we have found gx for which integration is same. Means if I integrate with 10x minus 1 by 2, if gx is 10x minus 1 by 2, then I can compute it. Now if okay, anyone can try. 10x minus 1 by 2. We did it and we got it, x. Now, if I do 10x minus 1 by 2, integration 0 to 10, then it should give the exactly same result. Let's try now. 10x minus 1 by 2, integration will come at 10x square by 2 minus 1 by 2x, 0 to 10. if I keep 0 to 10, okay, how much it will come? 0 to 10. Okay, it will come as it will come as hup, 10x square by 2. Then I'm sorry, yeah, 10x square by 2 minus hup. What is the gx? Gx is 10x minus 1 by 2. 10x square by 2 minus 1 by 2x. Okay, 10, 10x, 10, oh, 1 by 2 I can keep outside. 10x square, or I can go with it anyway. 0 to 10. 10x square will become 10 into 10 square. Up. Is it like that? Oh, sorry, it is 0 to 1. The integral is 0 to 1. It will become 10 by 2 minus 1 by 2. 10 by 2 minus 1 by 2. It will become 4.5. 4.5. Okay, if I add this again manually, 1 by 10 plus 2 by 10, it will become 1 plus 2 plus 3 plus 4 up to 10 by 10. How much is 1 plus 2 plus 3 up to 10? Up to 4 it is 10, plus 5 15, plus 6 21, plus 7 28, plus 8 36, plus 9 45, plus 10 50. 50 by 10, 5.4. We are getting 4.5. Some limit is missing. We'll try. We did limit 0 to 1, but we had taken chopping. While chopping, we took from, if I remember, we took it from the we took it from the 1 by 10. Let's try with 1 by 10 to 1. 1 by 10 to 1, how much it will come? Okay, if it works, I don't know. If it works, 1 by 10 to 1, 10x square by 2. 1 will be 10 by 2 minus 1 by 2, 4.5. First is coming. With the 10, with the 1, it is coming 4.5. Okay, now let's try with the 1 by 10. 1 by 10, if I make 10 into x square by 2, that will be 1 by 20. 1 by 20 minus, and then 1 by 2x. 1 by 2x, 1 by 20 is 0. Means it will come 4.5 only. Okay, we'll try one more thing. Now we are seeing here, if I add, let's add between 0 to 9. I'm sorry, add 1 to 9. Let's add 1 to 9. If someone add 1 to 9, it will come exactly 45, 4.5. Here also it is coming as 4.5. It is coming as 4.5. What about if this is approximation only. What we got it? We got 10x minus 1 by 2. 10x minus 1 by 2. For which integral is coming as 10x square by 2 minus 1 by 2x. Where 1 by 2 I can keep outside. Okay, x I can keep outside. It becomes x by 2, and in bracket 10x minus 1. This is what we are saying. Okay, let's make it 1. 10x minus 1. X is outside. 1 we are missing. Outside whatever we have x, let's place it as x plus 1. X plus 1. Let's try again. X plus 1 by 2, and in bracket 10x minus 1. Okay, 0 to 1, if I put integral, then it is coming as, now we'll try again. X plus 1, that is x plus 1, that is 2. And inside it is x is 1. Something like that. Anyway, this is better result. We'll try again. 10x we are getting as x by 2 outside, and then in bracket x minus 1. Okay, x by 10x minus 1. 10x minus 1. Okay, x we are keeping outside. If I put x as 10x as 1, we are getting 9 there. We are getting 9 there. Outside we have x. So we have 10 into 9 by 2. I think so. Okay, and that's why it is 45. That's why it is 45. Okay, 10x minus 1. X I am taking as 1. What I am trying to say, 1 we are missing. 1 we are missing. Okay, if I say let's chop it again, let's chop it again. We chopped 10 times beginning from 1 1. This is called approximation. Okay, we started with the 0 and we chopped it 10 times. This is x-axis and we chopped x equal to 0 to 10. Okay, we chopped 10 times starting from 1 by 10. 0, I'm sorry, this is 0 and this is 1. We started at x equal to 1 by 10. We chopped 0 to 1 x-axis into 10 different parts. Where we started with 1, 1, 2, 3, 4. Let us start with 0. Okay, if I start with zero, then if I start with what I'm saying is if I shift this considering or something like that, consider that or whatever hope again problem. Okay, if I do like 6, then it will become 9. One we are missing. What we are getting is 10x minus 1 in bracket outside x by 2. This is what we are doing. What we are missing here is we are trying to sum 1 to 10, but result here getting 1 to 9 only. Okay, means if I put x equal to if I put x equal to 1, if I put x equal to 1, I'm getting result of 1 less. This is what I'm saying. People can adjust here. Okay, this is the way that through integral calculus successive approximation we get the result. This is exact result. Okay, what about if I chop it into 100 times? If I chop it into 100 times, then what we had got the gx. Gx is 10x minus 1 by 2. If people remember, it is 10x minus 1 by 2. If I make it 10x plus 1 minus 1 by 2, then 10x plus 10x plus 1 by 10 or 10x plus 1, 10x plus 1 minus 1 by 2, then okay, then we will have 10x plus 10, 10x plus 10, okay, minus 1 by 2. Hope that will be something different. If I say 10x plus 1 by 10, what I'm trying to say, it is x plus 1 by 2. If I do like then x plus, instead of 10x minus 1 by 2, 10x plus 1 by 2. If I do like so, then how much it will come? 10x square by 2 plus 1 by 2x, 0 to 1, 0 to 1. Then it will become 0 to 1, 10x square by 2. First will become, first will become 4.5. I'm sorry, first will become 5. And another, oh, we are getting the result. No, yeah, we are getting the result. Okay, means what I'm trying to say is that x 10x minus 1 by 2. Okay, here result is coming as 1 degree less. 1 degree less means this I'll add 1. Makes sense? Yes, we are doing successive approximation. So what result we are getting? Result is not perfect. It is coming one stair less. We will add 1 here. 10x minus 1 by 2 plus 1. 10x plus 1 by 2. We'll try again. 10x plus 1 by 2. Now gx I have transformed into 10x plus 1 by 2. Means we are nearing. Now let's try integrating it. 10x square by 2 plus 1 by 2x, where limit is 0 to 10. If I say limit is 0 to 10, then it will become, I'm sorry, 0 to 1. Then it is 10 into 1 by 2, 5, plus 1 by 2, 0.55. It will come as 55, 5.5. This is what it is, I believe. Up till 9 addition is 45. Up till 9 addition is 45 plus 10, 55. Exactly same. Anyway, someone can try for 20, dividing into 20 parts. If I divide into 20 parts, how much is 1 plus 2 plus 3 plus up to 20? Okay, that is 20 into 21 by 2, as far as I know. N into n plus 1 by 2. 20 into 21 by 2 will become 210. Let's try here. 10. Now, instead of 10x, it will become 20x. 20x. 10 is because we had divided into 10 parts. 20x, 20x plus 1 by 2 will try. 20x square by 2 plus 1 by 2x. Well, it is 0 to 1. 20x square 0 to 1. 20x square 20x square by 2 will become how much? 20 by 2, 10. 10 plus 10 plus 1 by 2, it will become 10 and half. It will become 10 and half. And here if I add 1 plus 20 plus 2 plus 20 up to 20 by 20, top will become 210. 210 by 20. Okay, that will become 21 by 2. That will tell exactly say. Okay, this is called successive approximation. Successive approximation, we started with gx equal to fx equal to gx dx, and gx become dfx by dx. From there we started. And we started doing a successive approximation considering for the fx at x equal to x, what is fx? And same, we did integration from x to next level, x plus 1 by n. We took 1 by 10, 1 by 20. I can do x plus x to x plus 1 by n, dx dx. If I start doing a successive approximation, we came to 10x plus 1 by 2. 10 is because I divided into 10 parts. So it will become nx plus 1 by 2. So we can write dx as nx plus 1 by 2. And how many times I am dividing it, then we get it. Okay, we will proceed. The concept is to find the actual e to the power t, e to the power c, t minus x plus e to the power c, t minus 1, t minus 2, like that. So fx is e to the power c t minus x, that is the fx. What will be gx? So that if I take only x equal to x, what I am trying to say is that our fx is e to the power t minus x. Fx e to the power t minus x is a function like this. I have to find another function called gx, that will be completely different function. And for this function, if I take at any x, what is the height? This height should be exactly same as for another function. If I take x at x, what is gx? And what is x plus 1 by n? Okay, if I multiply gx height with this width, this will give the sub area. This sub area should be same as fx. E to the power c t minus x should be exactly same as integration x to x plus 1 by n, because I have divided n part 1 by n. If I take 0 to 1, or whatever the next portion is, next cut is x plus next cut gx dx. If I make this, then I will come to gx. Then I'll try to solve it. If there is any something different is there, I'll resettle it, and then I'll try to find the solution. Okay, we'll proceed. I'm really sweating. We will proceed in this, and we will try through the successive approximation to find a gx, that is a new function. We are calculating e to the power c t minus 1 plus e to the power c t minus 2 up to e to the power 0 through integral calculus. For integral calculus, if I consider this as a function, e to the power c t minus x is a function, then I have to come to another function as gx, for which gx dx from limit, here limit will be 0 to t. There are t terms here. 0 to 2, x will be 0 to t. 0 to t, gx dx should give same result what we are doing, e to the power c t minus x, e to the power c t minus x up to t terms, or e to the power c t minus x should be same as integration x to x plus 1, because we are making x as 1 2 3 4, x to x plus 1 dx dx. Find gx. Okay, and then we'll try to solve it, what it will come. Repeated, we can find it through repeated addition also, that we have already done in the past video, through repeated addition. And it comes as 1 by c e to the bracket e to the power ct minus 1, that we have already done it. And this is what is available in the book. But let's try to get through integral calculus, what it comes. Okay, these are things that are research based, not available in any of the books. If someone is master in this area, he can crack anything. Any problem in mathematics can be transformed into integral calculus. Any problem. This with this fundamental. And then its solution is perfect and much easy. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone number.